Welcome, everyone. Today, we will explore the fascinating world of artificial and intelligential intelligence, delving into its various branches and applications. Ah, our focus will be on understanding the core components and the transformative impact of AI technologies in our daily lives and across different industries. By the end of this discussion, you'll gain insights into generative models, their types, and applications. You'll also be familiarized with how generative models generate new content. You'll also come across case studies on their successful implementation in the industry and get a glimpse of the current landscape. Let us get started. So, let's start with the basics. What exactly are generative models? In simple terms, these models aim to generate new, plausible data points that resemble the data they were trained on. Unlike models that just classify data, generative models learn the underlying patterns and structures of the data. Think of it this way. Generative models capture the joint probability distribution of the data, which is, well, a fancy way of saying they understand how different parts of the data relate to each other. This allows them to create new instances by sampling from this learned distribution. So, what's the core difference? Well, generative models learn the distribution of the data to generate new data points. For example, a model trained on a dataset of human faces can generate new, realistic images of faces. Meanwhile, discriminative models learn the boundary that separates different classes within the data. Given a new data instance, they predict which class it belongs to based on these learned boundaries. For instance, a discriminative model trained to differentiate between cats and dogs can classify new images as either a cat or a dog. As the diagram shows, generative models sample new data points from the model, while discriminative models focus on decision boundaries separating different classes. In summary, generative models are about understanding and generating data, while discriminative models are about classifying and making decisions based on data. Now, let us see the different types of generative models. Now that we have a basic understanding of what generative models are, let's dive into the different types. Each type has its unique approach and applications. We'll cover variational autoencoders, generative adversarial networks, autoregressive models, and diffusion models. Let's start with variational autoencoders, or VAEs. These models are designed to encode input data into a latent space and then decode it back to the original data space. Imagine compressing a picture into a compact form and then reconstructing it, as shown on the slide. VAEs are great at generating new data points that resemble the training data. They consist of an encoder, which compresses the data, and a decoder, which reconstructs it. During training, VAEs balance the reconstruction error with the complexity of the latent space. You'll find VAEs being used in generating images, data compression, and even anomaly detection. Next up, we have generative adversarial networks, or GANs. GANs use two neural networks, a generator and a discriminator, trained together in a sort of cat-and-mouse game. The generator creates fake data, while the discriminator tries to tell if the data is real or fake. The generator aims to produce data so realistic that it fools the discriminator, while the discriminator gets better at spotting the fakes. This adversarial process continues until the generator produces highly realistic data. As shown in the figure, when training begins, the generator produces obviously fake data, and the discriminator quickly learns to tell that it's fake. As training progresses, the generator gets closer to producing output that can fool the discriminator. Finally, if the generator training goes well, the discriminator gets worse at telling the difference between real and fake. It starts to classify fake data as real, and its accuracy decreases. GANs are famous for generating images, translating images, and enhancing image resolution. They've also been used to generate realistic videos and synthesize music. Moving on to autoregressive models, like GPT-3. These models generate data by predicting the next value in a sequence based on previous values. They're particularly effective in generating sequences like text, audio, or time series data. For example, GPT-3 generates text by predicting the next word in a sentence based on the preceding words. In the example shown on screen, the blue line represents the actual time series data, and the red line shows the predictions made by an AR model. The model captures the underlying patterns in the data and generates accurate forecasts. You'll see autoregressive models used in tasks like text generation, language translation, and conversational AI. They're also great for speech synthesis and music generation. Lastly, we have diffusion models. These models generate data by iteratively refining a noise-initialized data point until it resembles the target distribution. Think of it like starting with a blurry image and gradually refining it until it becomes clear, as shown on the screen. Diffusion models start with random noise and refine it through a series of steps, reducing the noise each time to get closer to the desired outcome. They're primarily used in image generation and are known for producing high-quality, diverse samples. Researchers are also exploring their use in generating other types of data, like 3D shapes and time series data. All right, that was a brief introduction to generative models and their types. Here are a couple of questions to think about. Can you identify some everyday applications where generative models might be used? And how might a discriminative model be useful in your daily interactions with technology? Take a minute and give it a thought. Hope you went through the given questions and must have landed on some answers, right? If not, let's move on to the next slide and see some of the exciting applications of generative AI in various fields. Now that we've explored the different types of generative models, let's dive into where these technologies are making a real impact. Generative AI is being applied in various exciting fields, from generating text and images to creating music and videos, and even transforming artistic styles. Let's start with text generation. Generative models are powering advancements in chatbots, allowing them to understand and respond to users naturally. These bots handle customer service queries, provide information, and can even engage in casual conversation. Beyond that, AI is also helping in content creation by generating articles, blog posts, and social media updates, streamlining processes in marketing and journalism. Moving on to image generation, AI is now capable of creating stunning artwork. It learns from existing styles to produce paintings, drawings, and digital art that are unique yet inspired by human creativity. Additionally, in image editing and enhancement, AI excels in tasks like removing imperfections, enhancing details, and even converting low-resolution images to high definition, revolutionizing photography and design industries. In audio generation, generative models are composing original music compositions by analyzing existing pieces. They're also mastering the art of voice synthesis, producing natural-sounding speech used in virtual assistants, audiobooks, and even helping restore the voices of those who have lost theirs. When it comes to video generation, one of the most talked about applications is Deepfake technology. It allows AI to create incredibly realistic videos where faces and expressions are convincingly swapped. This technology, though controversial, showcases the immense potential of generative models in video synthesis. Moreover, AI aids in creating entire video sequences, characters, and scenes, transforming industries like film production, animation, and virtual reality. Lastly, style transfer is another fascinating area where AI shines. It can take the artistic style of one image or video and apply it to another, transforming photographs into masterpieces reminiscent of famous paintings or giving videos a completely new visual identity. These applications illustrate how generative AI is reshaping industries and expanding creative possibilities. From enhancing digital content to pushing the boundaries of artistic expression, these technologies are at the forefront of innovation. Next, let's explore how generative models actually generate new content. Understanding this process will give us deeper insights into the magic behind these remarkable applications. Now that we've seen where generative AI is applied, let's explore how these models actually create new content. It's a fascinating process that involves understanding latent space, the training journey, and how data is harnessed to produce realistic outputs. First up, understanding latent space. Generative models learn to represent data in a compressed, abstract form called latent space. This space captures the essence of the data's patterns and variations without explicitly storing every single data point. Think of it as a compact yet comprehensive blueprint of what the data can look like. Moving on to the training process. It all starts with gathering and preparing data. Generative models thrive on large, diverse datasets that reflect the domain they're working in. Data undergoes pre-processing, cleaning, normalizing, and sometimes enhancing it to ensure the model gets the best input for learning. During model training, the magic happens. The model dives into the data, adjusting its internal parameters to understand its underlying distribution. This involves complex algorithms and neural network architectures tailored to the specific generative model being used. Throughout training, the model aims to minimize the gap between the generated content and real-world examples. Evaluation metrics play a crucial role. We assess models based on fidelity, how closely generated samples match real data, diversity, how varied outputs can be, and novelty, whether the model can create entirely new content. Now, generating new data. Once trained, generative models can create new content by sampling from the learned latent space. Imagine randomly exploring this space and translating those points back into meaningful data, like images, music, or text. For more specific outputs, models can be fine-tuned. This involves tweaking the model further with additional data or specific instructions. This way, generative AI can cater to specific needs, whether it's generating art in a particular style or composing music with a specific mood. By understanding these processes, we unravel how generative AI powers everything from lifelike images to compelling music compositions and even deeply engaging stories. Next, let's explore some real-world examples where generative AI is already making a significant difference. Today, we're diving into some fascinating case studies that highlight how generative AI is making a real impact across various industries, such as healthcare, finance, retail, entertainment, and manufacturing. These examples showcase successful implementations that are transforming processes, enhancing accuracy, and driving innovation. Let's start with healthcare. Generative AI is revolutionizing medical image analysis. By analyzing MRI scans and X-rays, AI helps radiologists detect abnormalities more quickly and accurately. This not only speeds up diagnosis, but also improves early detection of conditions like cancer, ultimately saving lives. Moving to finance, where generative models are deployed in fraud detection. These models analyze transaction data to identify suspicious patterns and anomalies, flagging potentially fraudulent activities. By doing so, they bolster security measures, minimize financial losses, and safeguard both institutions and customers. In retail, generative AI powers personalized shopping experiences through recommendation systems. These systems analyze customer behavior and preferences to offer tailored product suggestions. This not only enhances customer satisfaction, but also boosts sales by matching offerings to individual tastes. Turning to entertainment, where generative AI is transforming content generation. From scripting movies to composing music and even creating virtual worlds in gaming, AI is pushing creative boundaries. This automation not only fuels innovation, but also reduces production costs, opening new avenues for content creators. Lastly, in manufacturing, AI-driven generative design tools are optimizing product design. Engineers use these tools to generate optimized designs based on specified parameters and constraints. This accelerates innovation cycles, cuts down design time, and improves product performance through AI's ability to explore and recommend optimal solutions. These case studies highlight the practical applications and tangible benefits of generative AI across diverse industries. By harnessing AI's capabilities, organizations are achieving remarkable improvements in efficiency, innovation, and customer satisfaction. Next, let's delve into the current landscape of generative AI. We'll explore who the key players are, recent breakthroughs, and what the future holds for this rapidly evolving field. Let's dive into the current landscape of generative AI, exploring the key players, recent advancements, and trends shaping this exciting field. First, let's talk about the key players and technologies. OpenAI stands out with their groundbreaking models like GPT and DALL-E, revolutionizing natural language processing and image generation. Google DeepMind is another leader, known for pushing the boundaries with innovations like AlphaFold for protein folding and WaveNet for realistic speech synthesis. Alongside these giants, universities such as Stanford and MIT, as well as tech giants like Facebook AI Research, FAIR, and Microsoft Research, are all driving forward with their contributions to generative AI research. Now, let's look at recent advancements. There have been significant breakthroughs in model architectures, especially with transformer models like GPT and BERT, which have revolutionized how we approach language understanding and generation. Meanwhile, improvements in training techniques, such as self-supervised learning and reinforcement learning, have boosted the capabilities of these models, making them more adept at handling complex tasks. Looking ahead, several trends and future directions are shaping the field. There's a growing emphasis on ethical AI, ensuring that generative models are developed and deployed responsibly. The integration of multimodal generative models is also gaining traction, allowing AI systems to understand and generate content across different modalities like text, images, and audio simultaneously. Moreover, advancements in hardware and algorithms are paving the way for real-time applications of generative AI, enhancing user experiences and enabling new practical applications across various industries. This dynamic landscape highlights the rapid evolution and broad impact of generative AI. As these technologies continue to advance, they promise to reshape how we interact with technology and solve complex challenges in innovative ways. Let's have a just a minute session. You can pause the video and try answering the question. The correct answer is option C, autoregressive models. Let's have another just a minute session. You can pause the video and try answering the question. The correct answer is option B, generative adversarial networks, GANs. Let's sum up what we've covered in this presentation. We've explored generative AI's fundamental concepts, wide-ranging applications across industries, mechanisms for content generation, the current landscape with key players and recent advancements, and impactful case studies. From healthcare diagnostics to fraud detection, personalized recommendations to creative content generation, and optimized product design, generative AI is driving significant advancements. Looking ahead, ethical considerations, multimodal capabilities, and real-time applications will continue to shape its future, promising ongoing innovation in artificial intelligence. That's all for the session. Thank you.